Object-oriented programming is intended to bring programming closer to thinking about the real world. An object represents an entity in the real world that can be distinctly identified. For example, a student, a desk, a circle, and even a bank account can all be viewed as objects. We understand that objects are separate from one another. They have their own existence, their own identity that is independent of other objects. Two same phones are not the same objects. They are different objects. They have their own identity. And we know that one object might contain other objects, but we still understand their separateness. This does not confuse us. We know that objects have characteristics, inherent properties that describe them. A glass can be full or empty. A computer can be on or off. These are the attributes or data of any object. Things like color, shape, size, and weight. Data within an employee object might indicate whether an employee is full-time or part-time, hourly or salaried. They describe the current state of an object, and the state of one object is independent of another. We turn one phone off, it does not turn all the phones in the world off. And in real world, objects have behavior. A phone can ring, an AC can control the room temperature. In this sense, an object acts like a small mini program that carries its own data. We understand that objects are separate from one another. They have their own existence, their own identity that is independent of other objects. Objects in a computer program are well contained, so they have identity separate from other objects. These three things, attributes, behavior, and identity, are the same three things that describe an object in an object-oriented programming language. Just as procedures are used to build procedural programs like in C, objects are used to build object-oriented programs. An object-oriented program is a collection of self-contained objects, each object containing its own data and its own logic, and they communicate between themselves to solve a problem. Every object contains data that describes the state of the object, has a set of defined behaviors that the object knows how to do, and has an individual identity that makes it possible to distinguish one object from another, just as it's possible to distinguish one program variable from another. Objects are very much like program variables in a procedural language. The integer variables I and j may have exactly the same value, say 3, and yet they are distinct variables stored at different locations within the computer's memory. Changing the value of I to 4, for example, does not change the value of j. Now, while in the real world we tend to only use the word object for things we can see and touch, but in computing we can take it further. In a computer program, we often have objects that represent real-world items like car, table, phone, but also a date could be an object. A bank account could be an object, and you cannot touch and hold a bank account in real life, but it is still a well-defined idea, and it meets our definition of object. It has identity. One bank account is separate from another bank account. It has attributes or data that describe its current state, an account number, a balance, an account holder name, and it has behavior. You can deposit to a bank account, you can withdraw from it, transfer fund, or inquire what the current balance is. And just as they don't have to be physical items, objects in a computer program are not just the things with a visual appearance on the computer screen. Buttons, images, and videos can all be objects, but so could invisible things like a thread or an array. So we don't just focus purely on a physical items or visible items when you are working with objects in a computer program. Now, when you are new to object-oriented design, it can be a bit of challenge to figure out if something in your application is a new potential object. A simple rule of thumb in identifying classes is to look for nouns in your problem analysis. Methods, on the other hand, correspond to verbs. Now the question is, where do these objects come from? They don't magically appear in our program. So how do we make them? Well, to do that, there is another word we must explore that goes hand in hand with object, and that word is class.